Hello. I said I was going to do a little backup video on my little cells, the great little cells I made, and here they are. They're still running away. Been 36 days now since I built them, started them up. There's one cell, there's another one, there's one over here, and they're running these little pulse motors. Hopefully you can see that okay. 36 days, 24 hours a day on these little homemade cells. I call them the great little cells on the other video. It shows how I made them and everything. I thought I'd do an update, let you know they're still doing great. I did add water to each cell about a week ago, a few drops of water. Pull the cap off the bottom and put a few drops of water in it. I have another one over here going too. But basically what I wanted to talk about today was a video Litmotor did. He has a little emergency solar backup system, and I also have one. Mine consists of 3 panels. I know maybe you can see them here. Change this around. I have them hanging from the eave. I have 3 of them. They're 15 watt, 1 amp, 12 volt panels. I have them all in parallel. And I have them feeding, you can see in my closet there, I have a battery box there that's vented to the outside, up through the roof. And in that box I have 3 deep cycle marine batteries. They do a heck of a good job. I got the voltage controller and all that stuff there, and I have a little emergency trickle charger in case we have shade for a few days. I can keep them up full charge. And they work really great. But what I wanted to know basically is what was happening with the drawdown on them. And Litmotor did that in his video, and with a little help from him I was able to accomplish it also. Let me go back over here. What I did is I went out and I bought a small inverter. It's a Stanley. And believe me, it's a 500 watt and it really works great. I tried some other ones and this one really did the job. Did a great job. I'm really surprised. Some of the other ones I tried were bigger and they wouldn't even light a 40 watt incandescent. This one lights them with no problem at all. On my system in the closet there, I have a 2000 watt inverter that I use to run the furnace or the refrigerator if we have a power outage. On this one, what I did is I took this little battery here and I put the amp meter in line on the positive side between the battery and the inverter right here, so I could read the amp draw. And this is the results I got on the incandescent bulb right here. It's a 40 watt. I got 3.47 amps was the drawdown on the battery. 12 amps that was drawing. This one here is a 20 watt CFL. There it is right there. And the amp draw on it was 1.99. It's a 75 watt replacement bulb. On the next one I did was a 13 watt CFL, and the 13 watt did 1.44 amps. That's a 60 watt replacement bulb. And over here I have a Lights of America. I did a test on it also to see what it would draw, and I found out it drew 0.41 amps. That's pretty interesting. The incandescent almost well, it's 3 3/4 amps down to less than a half an amp for the Lights of America. The inverter, I found out, did a test on it by itself when it was in standby. In standby it was drawing 0.21 amps or 210 milliamps, which I thought was really great. As my big one, the 2000 watt one I have, it draws an amp just in standby. So I thought to get an accurate reading on these, I'd probably have to subtract that 0.21 from my other readings here, because I'm sure that 2-light LED would probably be only drawing about 20 or 200 milliamps. Anyway, it worked out real good, and a special thanks to Lit Motor for helping me do it right. I was doing it, but I wasn't doing it right. I was taking a reading between the inverter and the bulb, and I needed to take it between the inverter and the battery to get an accurate reading. So it worked out really great. These little guys are still spinning away over here, as you can see. By the way, I checked the voltage on them yesterday, and I just did a couple of the batteries at random there, the little cells. And I had 1.29 with no load, and just a tiny bit over a volt with a load on. So they're still going to be going for quite a while yet. I'll do a little update on them again sometime. I have a third one over here just spinning away like crazy too. It's just hanging on a needle. And of course I still got all my junk going, all my toys. Lots and lots of them. Let me take this off of the flower for a second. See a few things going on here. I've been working on jewel ringers and jewel thieves and all kinds of stuff. A lot of little projects going. See some of them up there. Still having a lot of fun. Well, I just thought I'd do an update on this bulb drawdown thing, and on myself the bulb drawdown thing. I thought it was very interesting. And today, while I'm sitting in here, the power I'm using here and up here to light my room is coming from my new little let me flip this over, I'll give you a little closer up of it. Here I'm on flower here. This is my new little inverter, the Stanley, that draws very, very little current in standby. And this is a 2000 here. It's a great one. Okay. I checked my drawdown on my battery just to see if they had dropped at all, because I used the lights in here like this all day yesterday, and I was still at 12.7 on the batteries, so they're doing pretty darn good. Well, hope you guys are all having fun out there like I am, and I'll say thanks again for watching.